All right, mathematicians, let's get to proving parallel lines, section 3.3. Our essential question: for which of the theorems involving parallel lines and transversals is the converse true? Our objectives: mathematicians will be able to use the corresponding angle's converse, construct parallel lines, prove theorems about parallel lines, and use the transitive property of parallel lines. All right, so here we have the corresponding angle's converse. Remember, converse is where you switch the hypothesis and conclusion. In the previous lesson, we had that if lines are parallel, then corresponding angles are congruent. Well, our converse states if corresponding angles are congruent, then the lines are parallel. So our implied also switches. Corresponding angles congruent implies parallel lines. So here it is as a picture. So this is an illustrative if-then statement. So if, and then here's a picture of a pair of corresponding angles. So angle 1 is congruent to angle 2. Then we can say that these two lines that angle 1 and angle 2 are a part of are parallel. All right, so let's take a look at example 1 where we can apply the theorem, the corresponding angle's converse theorem. We want to find the value of x that makes line M parallel to N. Well, looking at the position of these two angles, so this position and this position, they are in corresponding angles positions. So we can set up that they are equal to each other. So 3x plus 5 equals 65. Solve for x, so subtract 5 on both sides, resulting in 3x equals 60. Divide both sides by 3, resulting in x equals 20. So if x equals 20, then line M is parallel to N. And that's using the corresponding angle's converse theorem. All right, our next theorem is the alternate interior angle's converse. So again, the previous conditional statement in the previous lesson was if lines are parallel, then alternate interior angles are congruent. Well, here we're switching, which is the converse. The hypothesis conclusion is now if alternate interior angles are congruent, then the lines are parallel. So in other words, alternate interior angles congruent will imply parallel lines. And then this is our illustrative if-then statement. So here's a picture of an example of alternate interior angles. And then we can say that if angle 3 is congruent to angle 4, then the lines that contain angle 3 and angle 4 are parallel. This is our alternate interior angle's converse. All right, let's also look at the alternate exterior angle's converse. So if alternate exterior angles are congruent, then the lines are parallel. So alternate exterior angles congruent implies parallel lines. Our implied statement, here it is as an illustrative statement. So if, here's an example, 5 and 6 are alternate exterior angles. And look at where they are in relationship to the lines A and B and the transversal. So we can say that angle 5 is congruent to 6. So if my alternate exterior angles are congruent, then the lines that contain 5 and 6 are parallel. So A is parallel to B. All right, and then we have our consecutive interior angles converse. So if consecutive interior angles are supplementary, then the lines are parallel. So consecutive interior angles supplementary implies parallel lines. Here's our illustrated if-then statement. So here's an example of our two angles. So here, 7 and 8 are not congruent. So notice they do not have markings that match. So I had to pause and add in my markings. So notice that the markings aren't matching. That means they're not congruent. But instead, these are the one pair of angles that are supplementary. So if I add their measures, it's going to total 180 degrees. So if my consecutive interior angles sum to 180, in other words, supplementary, then the lines that contain those two angles are parallel. All right, so let's take a look at the next theorem we have is the transitive property of parallel lines. And it states that if two lines are parallel to the same line, then all three lines are parallel. So our implied two lines parallel to the same line implies parallel lines. So let's take a look at it as an illustrated statement. Here we have three lines. We'll call them P, Q, and R. So what this is saying, this transitive property states, is if line P, as we can see here, is parallel to line Q, and line Q is parallel to line R, and we see our matching parallel marks, then we can conclude that the first one is parallel to the third one. In other words, they're all parallel to each other. That's our transitive property of parallel lines. All right, so let's take a look at this example. We want to find the value of x. Well, you can see that x is kind of right here at an intersection of two rays, so an angle. And then we can see by the parallel markings that these two lines are parallel. So we can consider this a transversal, however, it stops right here. And I don't have another line that it's hitting that could potentially be parallel to this line. And then we have what looks like a different transversal going off in a different direction, hitting this second parallel line. So maybe if we sketch in a third line parallel to the original two, that will help us. And there we go. So I've sketched in a third line that is parallel to the first two, using the transitive property of parallel lines. So now I can use this as a transversal. So what angle 145 degrees here, I can then make a conclusion about any of the angles that it's touching. So 145 would be supplementary to this angle, or it would be vertical to this angle. It's also supplementary to this angle, linear pair. So I've got options to kind of consider here. And that would allow me to figure out this angle. Well, if I can figure out this angle, which is supplementary to 145, that's going to get me 35 degrees. And if this is 35 degrees and its alternate interior is also 35 degrees. So that gets me part way to figuring out x. Now I can look at this line and this line parallel to each other with this transversal. And if this is 40, then this is 40 because of alternate interior angles. So if I can make this 40, identify this as 40 and this is 35, I can add those together and get 75 degrees for x. So let's take a look at all this information together one more time as it is now presented completely in the image here. We've got vertical angles, so 145 is vertical to 145 here. And then this 145 is consecutive with this angle, therefore supplementary, making it 35 degrees when you subtract from 180. And then if we go to this picture with parallel lines here and this transversal, we've got 40 and 40 here, which is alternate interior angles, and alternate interior angles are congruent. So then we have this 30 and this 35 and this 40 adding together to be 75. So x is 75 degrees. All right, let's take a look at this next extra example, finding x and y. So again, look at your angles in relationship to the three special lines. Two of the special lines are the ones that are going to be marked parallel. The third special line will be the transversal that cuts through the two parallel lines. When you can identify those three lines, then you have all the angle relationships that you can identify. So like in this case, I can identify 10x plus 5y angle consecutive with 80 degrees, therefore supplementary. So this one plus this one can add up to be 180 degrees. I can do the same for this transversal, cutting through the two parallel lines. So 72 is consecutive with 15x plus 4y, therefore supplementary. So consecutive interior angles being supplementary allows us to write two different equations set up equal to 180, simplified, so 10x plus 5y plus 80 equals 180 is your first equation, and that's with this angle and this angle, consecutive angles. Then 72 plus 15x plus 4y being supplementary, adding up to be 180. Then take 10x plus 5y and then subtract 80 from both sides to get the 100. Here we'd subtract 72 from both sides, simplifying the second equation to 15x plus 4y equals 108. Notice I have two variables in each equation. The only way you can solve a set of equations like this where you have two variables is using a system. So we have strategies for solving a system. So let's talk about that. All right, solving a system, there are multiple ways to solve a system, but one way is by elimination. So what that means is I need a variable, either one, x or y, doesn't matter which one you choose. I need a variable to have a zero sum. Well, in this case, right now I have coefficient 10, coefficient 15, so there's no way I can zero out my x's. For the y's, I have a coefficient of positive 5 and a coefficient of positive 4. I cannot zero these out either. So that just means I have to multiply each equation by some value that does allow me to zero them out. So we're going to multiply both equations so one of the variables' coefficients are the same number with opposite signs. So I'm going to multiply the first equation by -3 and the second equation by 2. And when I do that, that allows me to have opposites for my coefficients of x. So a -30 and a positive 30 is going to zero out, and that's what we want. So my second step then is to add down and solve. So line up the variables and constants, add down, and solve for the variable. This is known as our elimination method. So here we have -30x plus 30x, which is going to be 0x. And then -15y plus 8y is going to equal -7y. -300 plus 216 is -84. Again, you're adding down. Now I have -7y equal to -84, so I divide both sides by -7. And so y equals 12. All right, next, substitute that value of y that we just figured out and solve for the second variable. So 10x plus 5 times 12 equals 100. That gives us 10x plus 60 equals 100. That gives us 10x equals 40, which gives us x equals 4. So our final answer can be written as variable equals or a constant point. What do I mean by that? So you can either list your variables with their equal values separately, so x equals 4, y equals 12. Or you can write it as a coordinate, an x, y coordinate, so 4, 12 in parentheses. All right, that's all for this lesson. Bring any and all clarifying questions to class, and we will practice these ideas. See you then.